This research paper introduces MVPbev, a novel two-stage method for multiview perspective image generation from bird-eye view. BEV. Semantics with test-time controllability and generalizability. Unlike prior methods, MVPbev addresses the limitations of neglecting layout consistency, lacking the ability to handle detailed text prompts, and being incapable of generalizing to unseen viewpoints. The first stage of MVPbev projects given BEV semantics to perspective views with camera parameters, enabling the model to generalize to unseen viewpoints. The second stage introduces a multi-view attention module with special initialization and denoising processes to enforce local consistency among overlapping views with respect to cross-view homography. This design allows for object-level control and novel view generation at test time. MVPbev further refines a pre-trained text-to-image diffusion model, enabling test-time instance-level controllability. The method is capable of generating high-resolution photorealistic images from text descriptions with thousands of training samples, surpassing state-of-the-art methods under various evaluation metrics. The authors demonstrate the advances of their method in terms of generalizability and controllability with novel evaluation metrics and comprehensive human analysis. They highlight the significance of their contribution, including a novel multi-view image generation method that produces semantically and visually consistent perspective RGB images from BEV semantics, a more controllable yet extendable algorithm, and state-of-the-art performances on large driving datasets. The authors also discuss related work in image editing and generation, focusing on conditional image generation and novel view image synthesis. They note that while generative models have made significant progress, multi-view or cross-view text-to-image generation still faces issues of computational efficiency and consistency across views. They highlight the limitations of existing work, including MV diffusion, BEV gen, BEV control, and magic drive, which failed to generalize to more dramatic viewpoint changes or smaller overlapping areas, and do not conduct human analysis on image generation quality. MVPbev is a novel method for generating multi-view perspective images from bird's eye view. BEV. Semantics with test-time controllability and generalizability. It consists of two stages. The first stage projects BEV semantics to perspective view with camera parameters to maintain global semantic consistency, and the second stage parses both perspective semantics and text prompts, generating multi-view images with both visual consistency and test-time instance-level control by explicit enforcing and latent. The method aims to generate multi-view perspective images from text prompts given pixel-level BEV semantic correspondences. It leverages both global and local consistency in implicit and explicit manners. The first stage ensures semantic-wise consistency between BEV and perspective views with the help of geometry constraints, leading to fewer accumulative errors at the generation step. The second stage enforces consistency implicitly among overlapping perspective views with a multi-view attention module. The multi-view attention module aggregates information from the target feature pixels in neighbor views to ensure visual styling consistency across different views. It computes the attention output based on the corresponding pixels in the feature maps generated by views on its left and right sides. This module follows a similar formulation as in 30, and is defined as an equation that includes learnable weights of query, key, and value matrices. MVPbev's method also includes a novel training initialization and denoising design to explicitly enforce visual cues at overlapping FOVs to be coherent. The overall pipeline of MVPbev can be found in Fig. 2, with more details of the first and second stages provided in Sec. 3.1 and Sec. 3.2 respectively. The model training process is described in Sec. 3.3. The proposed method, MVPbev, is a multi-view perspective image generation model that leverages a latent diffusion model, LDM, with test-time controllability and generalizability. The model is trained using a multi-view LDM loss, which consists of a variational autoencoder, VAE, with an encoder, decoder, denoising network, and condition encoder. The input image is mapped to a latent space, and the denoising network is a time-conditional U-net that incorporates cross-attention mechanisms to leverage the condition encoding. The model is trained using a shared noise level for all multi-view images, and the noise values are enforced to be consistent across views. During inference, the denoising process generates samples in the latent space, and the decoder produces RGB images with a single forward pass. The model also allows for instance-level controllability, where the user can click on the target instance and provide color-specific requirements. This is achieved through a special mechanism that manipulates the response of cross-attention layers to accurately guide instance-level synthesis. The model is evaluated on the NuScenes dataset, which provides full 360-degree coverage with 6 cameras. The evaluation metrics include image quality, visual consistency, semantic consistency, and object-level controllability. The results show that MVPbev outperforms state-of-the-art methods, including BEV Gen, Magic Drive, ControlNet, and MVD, in terms of image quality, visual consistency, and semantic consistency. The human analysis also shows that MVPbev is able to generate more visually and semantically consistent images compared to other methods. Additionally, the model is able to achieve better object-level controllability, where the generated objects meet the targeted color requirements. The implementation details of the model are also provided, including the architecture, hyperparameters, and training settings. Overall, MVPbev is a powerful model that is able to generate high-quality, consistent, and controllable multiview perspective images. MVPbev, multiview perspective image generation from BEV with test-time controllability and generalizability. 24. October 28 to November 1, 2024. Melbourne, Victoria, Australia. This paper introduces a novel two-stage method called MVPbev for generating multiview perspective RGB images from text prompts given BEV semantics. The first stage projects BEV semantics to perspective views, and the second stage performs image generation with respect to both text prompts and individual perspective semantics. The authors compare MVPbev with baselines and report the performance in Table 1. MVPbev ranks first among comparable baselines, such as ControlNet and MVD, and achieves comparable results to SOTA methods trained with far more training data. Visual comparisons are provided in Figure 6, showcasing the most consistent perspective images generated by MVPbev, especially at overlapping FOVs. Qualitative results are shown in Figure 7, demonstrating MVPbev's ability to generate visually consistent images from diverse BEV semantics and text prompts. The authors also highlight MVPbev's test-time controllability and generalizability, particularly its ability to handle viewpoint changes without retraining the entire model. In addition, the authors conduct experiments to showcase object-level controllability by including an additional description of the object color in the original text prompt. They report qualitative evaluations in Figure 9 and qualitative examples in Figure 10, indicating that MVPbev provides better generalizability and object-level controllability. Human analysis is conducted to provide a more reliable tool for image quality measurement. The results in Table 1 show that MVPbev outperforms baselines significantly, indicating that it can generate photorealistic yet consistent images. Furthermore, MVPbev provides better generalizability quantitatively and achieves a high rate of correctly generated instances in terms of object color. In conclusion, MVPbev is a novel method that generates multiview perspective RGB images from text prompts given BEV semantics. It demonstrates superior performance under various metrics and test-time generalizability, making it a valuable contribution to the field of image generation. Here is a combined summary of pages 9 and 10. The paper presents MVPbev, a novel approach for multiview perspective image generation from bird's eye view, BEV, with test-time controllability and generalizability. The method leverages a diffusion-based framework to generate diverse and realistic street view images from a given BEV layout. The authors acknowledge the support of the National Natural Science Foundation of China and provide an extensive list of references, showcasing the paper's foundation in various computer vision and machine learning concepts. The proposed MVPbev method consists of a bird's eye view encoder, a diffusion model, and a controllable image generator. The bird's eye view encoder maps the input BEV layout to a latent representation, which is then fed into the diffusion model to generate a diverse set of latent codes. These latent codes are then passed through the controllable image generator to produce the final Street View images. The controllable image generator is designed to allow for test-time controllability, enabling the generation of images with specific attributes, such as lighting conditions, weather, or time of day. The authors demonstrate the effectiveness of MVPbev through various experiments, showcasing its ability to generate realistic and diverse Street View images from a given BEV layout. The paper also provides a comprehensive review of related work in the field, including image synthesis, diffusion models, and neural radiance fields. The authors highlight the limitations of existing methods and demonstrate how MVPbev addresses these limitations through its novel approach. Overall, the paper presents a significant contribution to the field of computer vision and machine learning, providing a new approach for multi-view perspective image generation with test-time controllability and generalizability.